Hello, my name is Faros Nisar. I'm a student at Explore Data Science Academy, and this is my Sandy Logistics Challenge for the linear regression sprint. So the problem that we're tasked with solving is to um, try and predict the time it takes for a courier to uh, deliver a product. So that's from pickup to arrival, so the time it takes from pickup to arrival, using a set of features that was given by Zendy. And yeah, and I think roughly 20,000 data points also provided by Zendy. So my approach is straightforward, I like to think. So I use linear regression. Um, I also wanted to use Ridge and Lasso, but I think I'll do that in my later iterations or later versions. For now, I'm just going to use the linear regression. So first of all, I import my data. Then I combine my data with, I merge my data with the training, merge my training data with the Redder data. So I have one big data frame that contains everything. Then I just rename all my columns just to make sure that they have the same format and they have this unique case format, which is the one that's mostly used in Python. Then I check for missing values in the data frame. So I drop one of the columns, precipitation, which has way too many missing values. And for the other column, which is temperature, I just um, I use the fill_nar function on the using the mean value. Yeah. I also check the data types for all the columns in the data frame, so I have a good idea of how all the columns look like. Then I convert some of those data types into categories. Then I split the data based on the data types, so I can perform EDA much better. So then I visualize the data itself. So here I'm visualizing the placement data of the month. So I group the arrival time, the time it takes for the couriers to arrive after picking up the orders. And then I visualize that using Powerplots. So I just to get a better idea of exactly which days have the least amount of time and which days have no amount of time as well. And I also noticed that some columns, some features actually don't have that much variance, so I drop those features. And I also through the EDA process, I also noticed that about I think about 500 to 600 rows are actually outliers. So those are all the rows that contain values that contains data points with um, ETA time of the time it takes from pickup to delivery with that's more than 4,000 seconds. So that's actually just outliers, and I just remove those. Okay, so after that, I checked for the correlation between my features and the target feature as well. And I noticed a high correlation between the placement day of month, placement confirmation day of month, arrival at pickup day of month, pickup day of month, arrival at destination day of month, and the corresponding day of the week and hour of pickup and so on. So I dropped most of those features and I just took one that served as a representative feature for all of them. Also created a graph that showed me the correlation between the time from pickup to arrival and all the other features, which just showed me that there's a really high correlation between time from pickup to arrival and the distance between pickup and destination. Also, I just made sure that my distribution for the time from pickup to arrival is actually normal, which is the case. and then I converted my categories into so that's my non I guess not my numerical categories. So those are the categories of variables that are actually represented by numerical values. I converted the numerical values into actual categorical values so that it would be much easier on the starting my variable encoding part of this project. So from there on, I started encoding the variables. So okay, I'm still categorizing the pickup period and so on. Then yeah, here that's where I encode the dummy variables. So using the platform type, personal or business, pickup day of month, pickup weekday, pickup time. So using those features, I was able to encode those features as dummy variables. Um, that way, I'm able to make the most of those category variables. So I also used OLS to fit a model. So that's the stats model OLS object, just to get a fitted summary. So I can have a good idea of my adjusted R score and which features have significant coefficients and so on. So that was informative. Sadly, my adjusted R squared was only 3.84, but I did have a good view of which coefficients had actually um, uh, insignificant or rather significant p-values and so on. So from here, so based on my EDA and feature selection, I was able to bring the list of features that I could actually use for prediction down to these ones. So those are the features that I use. And then I created my final training data set and test data set. And then I used the sklearn min-max scaler to scale those columns. Then I created my X and Y barrier matrices and my X test matrices as well. And then using the train test split from sklearn, I split my data into X-train, X-val, Y-train, Y-val, and I fit that to my linear regression model, LM. And then from there, I was able to predict based on my X value um, and calculated error. So my RMSE, which is my error value, came down to 630, which is very low. And I think based on the theory of bias variance trade-off, it's actually bad because it means I overfitted. So the moment I run my model on a new data set, it will actually, the error will be very high. So yeah, it's not actually, but I intend to fix that. So that's my presentation. That's my Sandy Logistics Challenge. I hope to make it better in the next day or two. But yeah, thank you.